back. Watch this.
Well, hello one and all, and welcome to our short on while loops. Now, life is full of surprises, and one surprise for me recently was taking care of this particular plant here. Now, it turns out this plant is pretty picky about the kind of water it gets and when it gets watered. I'm supposed to water this plant when the soil is dry, but not too dry, and so I have to kind of check every day what the moisture level is before I should actually know, should I water this plant or not. So I thought I could write a program to remind myself when to water this plant, depending on how dry the soil is. And one thing I've learned is that you can actually measure the moisture content of soil in percent water out of all the entire soil you might have. And soil is considered dry, supposedly, when it reaches a moisture level of 20% or a little bit less. So ideally here, I could write a program to maybe check for me once a day, let's just say, what the moisture content of this plant's soil is, and if it's 20 or less, go ahead and alert me that I should be watering this particular plant. So here I have a program called water.py, and this program actually uses a function called sample that I've written elsewhere, but I'm going to just import it and use it in this program. No need to worry about how that's implemented in this case. The purpose of sample is really to just sample my soil, hypothetically in this case, and maybe return to me the percent moisture that it has sampled from the soil on this particular day. So my program in main here is as follows. I'm going to sample my soil, store the result in moisture, and then print out the current moisture percentage, or the water content at least, of this particular soil on this particular day. So go ahead and run Python of water.py, and what do we see? Well, today the moisture is 28%, so not quite dry enough to water. But what should I do now? This program only checks once for me. I'd love for it to maybe keep checking while the soil is still wet. And I'd love for it to stop when the soil is dry and alert me that it's time to water this particular plant. So notice how I said there I wanted to do something while some condition is true. I want to keep checking the soil, sampling, while the soil is wet. So I could use, let's say, a while loop. A while loop is great when I'm not quite sure how many times I want to loop, but I do want to loop while some condition is true. Why don't I go ahead here and maybe update this program to be a little more dynamic and keep looping while some condition is true. I'll say maybe while the moisture content, moisture in this case, is greater than 20. That is, the soil is still wet. I want to do the following. I want to, well, sample again. Maybe it's another day, I'll sample the soil again, and I'll then report on the actual moisture content, the water content of this soil here. So now, what we've done is updated our program, and from top to bottom it reads like this. I'll first sample the soil, perhaps immediately after I water it, let's say. I'll start running this program. It will then report to me the moisture in that soil, and I'll then, let's say, while the moisture is greater than 20, while the soil is still wet, I will sample, let's say once per day, the moisture, and then report to myself the moisture that I need to, the moisture content as it currently stands. Now this while loop, the code that is indented inside of it, again, will keep running while this Boolean expression is true. But once it's no longer true, we'll actually exit out of this loop and, in this case, end our program. But before we do, maybe I'll do this. I'll say time to water, because I know that if moisture is not greater than 20, well, it's equal to 20 or less. So I'll go ahead and say it's time to water. Your soil is getting too dry. All right. So why don't I go ahead and maybe try this program now. I'll run Python of water.py, and I'll see that we could maybe, just for the sake of the magic here, assume this happens once a day. So the first day, 34% moisture. Next day, 31%, then 27, 23, 22, and 18. Now 18 is definitely not greater than 20, so we would then exit our loop and say time to water. But as long as moisture was greater than 20, we were, as you notice, continuing to loop as we went through. Now let's just try this again one more time, and we'll see that seemed to take a little bit more time here. Why don't I try this again? That seemed to take only 3 days. So really, soil moisture content can vary based on the weather, the sun, etc. And it might really be somewhat random how dry or wet my soil becomes over time. Now here, the magic of the while loop is that no matter when this happens, whether it's 4 days in, 2 days in, 5 days in, it's always going to end when this condition is no longer true in this case. And to make this point even more clearly, let's go ahead and add in a variable called days, and we'll say the day I first start watering is days equal to 0, and then every time I iterate, I'll add 1 to days. So going from 0 to 1, then 1 to 2. Every day I sample my soil again and again, and I could actually make it clear what day it is. I'll say days, and days here. And now if I run my program again, and make this just a little bit bigger for ourselves here, I should hopefully see that this time it took 5 days, indexing from 0. This time it took 6 days, indexing from 0. And this time, well, it only took 3 days. So again, while loop, the perfect choice when you want to keep looping while some condition is true, but you're not exactly sure how long you're going to loop at the end of the day. Good for things like randomness. Good for things like this, where you have a plant, you're not sure when to water. This was our short on while loops. We'll see you next time. Well, hello one and all, and welcome to our short on lists. Now we'll be exploring how we can store information in certain orders within Python. And I have here a game called Super Mario Kart, which, if you're not familiar, is a racing game for the Nintendo Entertainment System way back in the, the 90s or so. And the idea is you would play as Mario, Luigi, Princess Peach, and race to get a certain place in the race, whether it was first, second, third, first, or fourth, whatever it was. We're going to make a list here to represent the racers and their place when they cross the finish line here. So I'll come to my terminal here, and I'll go ahead and code results.py. And to make a list in Python, well, I can think about how I want to store these racers. Maybe Mario came first, followed by Luigi. So Mario in first place, Luigi in second place. I could make a list in Python by first giving it some kind of name. So here, I'll give this list the name results, just like this, results. And I'll say results equals, in this case, well, a list. And a list in Python is denoted by these brackets here, these square brackets, opening and closing. Now within these two brackets, I can actually place this information in the order I want it to be. So first, I could place Mario, saying Mario came first in this particular race, followed by, in this case, Luigi, just like this. And notice how each of these elements is separated by a comma. So Mario came first, followed by Luigi. So here, I've created a list just explicitly on my own. I made a list, add the elements, and so on. But often in Python, you might have a list you want to dynamically add to as your program runs. Here I've initialized a list, but how could I keep adding more racers in this case? Well, let's say after Mario and Luigi comes Princess Peach. So I could, if I wanted to add on to this list, use a method called append. Append adds a new element to the end of this list here. So I could try results.append. I take my name of my list, use dot, and then append to add on some new element at the end of this list. And back in the Super Nintendo Entertainment System era, Princess Peach was actually just called Princess, so I'll use that name here. And I'll add the princess to our list here, saying that she came in third. Now let's see where we're going here. So if I were to print the results, I can use print here and just call print results. I can then run Python of results.py, and down below, I'll see Mario, Luigi, and Princess. So Mario in first place, Luigi in second place, and Princess in third place so far. Well, maybe as the race goes on, we have more racers who finish, so I could keep appending if I wanted to. I could say results.append, and maybe after Princess comes, let's say, Yoshi, another player you can play in this game. After Yoshi comes Koopa Troopa, and then after Koopa Troopa comes, let's say, Toad. So these are our results. I'll go ahead and run python results.py, and now we'll see our results for the first 6 finishers. Again, Mario in first place, Luigi in second, Princess in third, and the rest following thereafter. Now, we could, if we wanted to, try to add more than one racer at a time. Maybe we get the results for Bowser and Donkey Kong Jr. at a pretty similar time, so we could try to add both of them at once to our list. One way to do this would be as follows. I could go ahead and say results.append and add on maybe a list to my list. I could try adding on, in this case, Bowser, followed by Donkey Kong Jr., and hopefully what we'll see is that these two elements, these two racers, Bowser and Donkey Kong, get added at the end of our list all at once. But let's see. If I were to run python of results.py, what we'll see here that we still have our first 6 or so finishers, but then at the end I'm noticing that Bowser and Donkey Kong Jr., well, they're added into our list, but they seem to be inside of a list themselves. Notice the curly brackets around their names there. So how could we fix this? Well, if we want to add onto our list using a list itself, we can't use append. Append actually goes ahead and adds the list itself to our list. So why don't I go ahead and remove this? I'll say results.remove, which is another method I can use to remove items, and I can give as input to remove the list itself. And why don't we do this instead? I'll say results.extend. Results.extend, and I can give extend now a list, but it will really take each element of that list and append it to, in this case, my original list called results. So to be clear, we're starting now with a list of 2 racers who finished, Mario and Luigi. We're adding in Princess, Yoshi, Koopa Troopa, and Toad, each individually. We tried to add the list of Bowser and Donkey Kong Jr., but we realized we can't use append for that, so we removed them instead. And now we'll try extending our list, which will take each of Bowser and Donkey Kong Jr. and add them individually to our results list here. So let's try this. I'll run python of results.py, and hopefully I'll see down below that we can in fact see all 8 now of our finishers, each on our list, with no sublists, if you will, inside of our one larger list. So here is an example of our list. Now we've added racers to it. What more can we do with lists? Well, let's go ahead and try to maybe take our list as it exists down here. I can really just copy and paste this. Actually, let me not copy paste. I'll come back up here and I will do results equals, and I'll type in Mario, Luigi, Princess, Yoshi, Koopa Troopa, Toad, Bowser, and Donkey Kong Jr. So a bit of a long list we have up here, but this will enable us to see a few more features of lists as well. So one other one we want to be familiar with is just getting a sense for what remove might actually do here. So here I have a list where Bowser is clearly part of this list. Bowser, it looks like, is in 7th place in this race, but I could remove Bowser entirely. I could say results.remove and then give as input Bowser. And this remove method will actually search through my list and find the first instance of Bowser and remove that element as well. So I'll run python of results.py, and we'll see down below that Bowser is no longer in our race. But let's say Bowser tries to cheat the system a little bit, and we remove Bowser, but we later go on and try to add Bowser back in. Well, we saw with results.append, if I were to append Bowser, Bowser would show up at the end of our list, in this case in 8th place, but we don't really want that for Bowser. Bowser would, of course, prefer to be in 1st place. So I could try this. I could try a new method, one called insert. And insert takes as its first argument the index at which I want to insert some given element. So recall how our lists are actually indexed from 0. 0 is the first element, 1 is the second element, and so on and so forth. So for instance, Mario here is at the 0th index, Luigi at the first index, Princess at the second index. So if I wanted Bowser to kind of sneakily move up to first place, I could try to insert Bowser, of course, at the 0th index, and say as the second argument the actual element I want to introduce, so Bowser in this case. So what have we done? We've had our list of results up here with Bowser in 7th. We've removed Bowser, but then later on we go back and insert Bowser in first, or at the 0th index as well. Let's try printing our results down below, and we'll see that Bowser appears now to be in first place at the 0th index of our list. Now, one more thing we can do with lists, one more method to consider here, is one called reverse. In fact, I can call results.reverse if I wanted to flip the standings a little bit, turn whoever is in 8th into first, whoever's in first into 8th, and I could actually run this now and see the result. And we'll see our list has been reversed. We have Donkey Kong Jr. now in first, who was previously in last place, and Bowser, who was previously in first place, is now here in first. So these are a few methods to be familiar with as you go off and do work with lists. We've seen here append, we've seen extend, we've seen remove, and we've seen insert, and of course at the end here we've seen reverse. That's it for this short on lists. We'll see you next time. Well, hello one and all, and welcome to our short on for loops. If you're familiar with the Mario video game series, you might be familiar with Princess Peach and her castle, Peach's Castle. And we'll imagine together that Princess Peach is inviting some guests to join her at a ball at Peach's Castle at 7 p.m. this evening. Now, thankfully, Peach has automated the process of writing letters to her guests. In fact, we have here a function called writeLetter, which takes in two arguments, one called receiver and one called sender. And notice how the purpose of writeLetter is to return to us a fully written and formatted letter to a receiver from the sender. In particular, we're using Python f-strings here to interpolate the values of receiver and sender. For instance, if our receiver were to be Mario, as it is on line 2 here, and our sender were to be Princess Peach, well, we should see at the end of this a letter that says, Dear Mario, and then some text down below, Sincerely, Princess Peach. And then we'll take that letter and print it out to our terminal to make sure everything is all correct. So let's see what happens if we run this program. I'll go ahead and open up my terminal here, and I'll run python of letters.py. I'll give us a bit more space so we can see all the letters fly by here. If I hit enter, well, we'll see some letters being printed out to each of our guests here. We see we invited Mario first, that seems good. Invited Luigi next, Daisy as well, and finally Yoshi. So this program seems to work, but there's a question of how well it's designed. If I were to show you again what this program looks like, let's think of some scenarios where this might get a little tedious. Let's say we're only inviting 4 guests now, but we also want to invite other folks too, in which case our guest list get pretty long. And to do that, I need to kind of copy and paste to add new letters to new characters as well. Now, if you find yourself in this kind of situation where you're repeating something for each maybe guest you have, you might think to use something like a for loop. A for loop, in fact, is great when you know how many times you want to iterate, or you want to do something, like write a letter for each person or each thing you have in some list, like a guest list in this case. So let's actually make ourselves a guest list and write a for loop to write a letter for each person on that guest list. Well, in main here, why don't I go ahead and update this program to instead keep track of a list that we're going to call names. And this names list will be our guest list for the ball. I'll go ahead and maybe add a few names to the guest list. I'll go ahead and add Mario here, and Luigi as well, Daisy too, Daisy and Yoshi, just like this. And now I have a guest list of names I'm hoping to invite. Well, now what should we do? We know we want to write a letter for each person that is going to be in this list. So I think I can actually get rid of this code down below here and instead think about how I could use a for loop. Well, one way to use a for loop, as we saw in lecture, is to use numbers and iterate over every number in some range of numbers. So I could write some code like this: for I, which is usually the name we give to some variable that is iterating, changing on each iteration, for I in, and then the Python range function. And range will give us a list of numbers from 0 up to, but not including, the value we pass in as input to range. So in effect, maybe I want I here to iterate, let's say, from 0, maybe the 0th index of this list, to 1, the first index of this list, to 2, the second index of this list, and then to 3, the third index of this list. Again, indexing from 0 with Mario here. So to do that, I can actually pass into range here the length of our list. Here I'm saying len of names, which in this case is 4, but range will give us 0, 1, 2, and 3. Let's try this out, though. I'll go ahead and print I down below, and ideally I'll see 0, 1, 2, and 3, each of the indices in this list here. I'll go ahead and run python of letters.py, and we'll in fact see 0, 1, 2, and 3. That seems to work just as well. But of course, we don't want to invite these numbers to our party. We want to invite Mario, Luigi, Daisy, and Yoshi. So one way to approach this is to use I to index into our list. I could do something like this. I could say names, bracket, I. And on each iteration, again, I will change. First it will be 0, then 1, then 2, then 3, giving us different names in our list here. I'm going to go ahead and run letters.py again, and we'll see now the names we're hoping to invite. And this is promising because I think I could actually use these as input to the write letter function. Let's try this. If I were to go ahead and print not just names bracket I, but the result of write letter given names bracket I as the receiver and Princess Peach as the sender, I think we'd start to get the same letters we saw last time. Notice a few things first here, though. Again, I will update on each iteration of our loop, that is from one traversal or time going from top to bottom in this indented code here. But what will change, what will actually stay the same, is Princess Peach here, the name that will be the sender. That will not change on each iteration because it doesn't depend on anything in our loop itself. So let's go ahead and run this. I'll run python of letters.py, and we'll see the same letters down below here as well. So same result, but what have we given ourselves here? I'm now able to make this program much more flexible, much more adaptable if I were to invite additional guests. We could, very quickly, let's say, add a guest like Bowser. Everyone is invited here. And we could print out a letter for Bowser just like that. No copying and pasting, just adding Bowser's name to our guest list. Now let's uninvite Bowser, actually, and think through some ways to improve the design of even this little segment of code here. Now this works. It's actually pretty well designed, but I think we could make it a little more readable, maybe stylistically better too. And we could do that using a feature of Python, which is we can actually iterate over any kind of list directly. This is a list here. Names is a list of, in this case, names. So we can actually use it as the second part of our for loop. I could say for I in names. And in this case, I will actually temporarily refer to each of the items in our list, or the names in our names list. I will first be Mario, then Luigi, then Daisy, then Yoshi, updating on each iteration. But I don't need to use I. In fact, I can give it any name I like as long as I am consistent with that name. I could say something more English-like, like for name in names, because we have a list of names plural, but each item is a single name, singular. So now, on the inside of my for loop, well, there's no longer an I variable to use to index into names, but I've conveniently given myself now this variable called name that I can just use. Again, first name will be Mario, then Luigi, then Daisy, then Yoshi, updating on each iteration as we loop through our for loop. And once we get to the end, once there are no more names, we'll simply stop looping and exit our program. Let's try it here. I'll go ahead and run python of letters.py, and we'll see the same results, but now with a bit better English syntax and probably better stylistically as we're writing programs like these. So for loops, again, are powerful when you know how many times you want to loop, or when you want to do something for each item you have in some list, or more generally, some iterable, something can be iterated over. This was our short on for loops. We'll see you next.
It's hard to focus. Yeah, newer segment of the course. I think it's the third one, the third bit. But yeah, this is where I started technically, and then I went all the way back. So it's been pretty nice to see how far I've come. Sorry there wasn't much doing. I was learning instead of my mic muted. So treat it as a throwaway stream, whatever, it's alright. I'll see you guys tomorrow though, where I can do actual work. I'm not gonna watch the last one because I'm already done as it is. So I'll see you guys tomorrow. Peace out. Actually, before I say peace out, I'll try to fix my procrastination before it gets any worse. So yeah, I'll see you guys tomorrow. Peace.